Work, follow along with me as I go. How did I do on my signs up here? Yeah.
All right. Are we ending at about the same spot?
Yeah.
All right, so let's go over this step by step. Okay. So our first derivative, where did the negative 2x come from, Michael?
Chain rule. It's the derivative of negative x squared.
Excellent. Nice job using the precise rule and the evidence from the specific problem. So the negative 2x came from the negative x squared and the chain rule. So when I was doing this problem for my own self, I put a big x through the e to the negative x squared when I did the sign analysis. Why did I ignore that piece of our derivative?
Because it doesn't exist when
no.
it equals 0.
Pardon me?
E of negative e of any power of x does not equal to 0.
Correct.
Doesn't
So
exist.
that's not going to give us a local extrema. Why could I also ignore it when I was doing the sign analysis?
It's always positive.
Correct. Michael, say that again louder.
It's always positive.
It's always positive. So the only value, when I'm doing my sign analysis here, the only value I need to plug into is this negative 2x. So when x is less than 0, negative 2x is positive, and when x is greater than 0, negative 2x is negative. Okay? So, oops. So I got 0, 1 is a local max. Where did the 1 come from, Spencer?
I plugged the 0 back into the original function.
Excellent. So we're increasing on the intervals from negative infinity to 0, decreasing from 0 to positive infinity. That matches my domain. Oh yeah, so to be clear, we were saying range before. What we meant was domain. Viewers at home, domain, not range, right? Because the range of what we just said, what Michael just said, is that we didn't need to evaluate it because the range is always positive, but the domain of e to the negative x squared is all real values. So that's represented in our intervals here too as well. Sorry about that. All right, so then we went to our second derivative. What derivative rule did we have to apply here, Shukai?
Product rule.
Correct. Explain this line of algebra to me, please. Where did
the
that come
second
from?
line,
Yes.
what you do is you use the product rule, so you have e to the negative of negative x squared. Which line am I talking?
Explain this line where the green arrow is.
Oh, okay. So when you did the product rule, and you see negative 2 on both, negative 2 times e to the negative x squared on both sides. So you can take them out by using distributive property, and then you take them out, and then you ended up with 1 minus 2x squared.
I had a big ol' X through this. Why do I have a big ol' X through that for my own work, Spencer?
It's not going to be 0.
It's never going to be 0. Why can I ignore it for my sign analysis, Shukai?
Because it's always going to be positive.
It's always going to be positive. So now I can just look at this piece in terms of determining any possible points of inflection, and then for the concavity. So set that equal to 0. I get possible points of inflection at plus or minus the square root of 1/2. So I want us to go back to the actual definition of points of inflection that you wrote down in your notebook. Read that again for us, Michael.
It's a point where the graph has a tangent line and the concavity changes.
And the concavity changes. So when I'm at this step, why did I just say that these are possible points of inflection?
You haven't done sign analysis on it yet.
I haven't done the sign analysis yet. So these are not definitely points of inflection until I have done the sign analysis and I have determined that yes, at negative square root of 1/2, it does change from negative to positive. And yes, at square root of 1/2, it does change from positive to negative. So now these are confirmed as points of inflection. How would I get the y values for these points of inflection, Michael? Excellent.
Um,
Which I could do. I was just being kind of lazy.
I have a question.
Yes.
I don't get why is it negative to positive to negative. Can you go over like what points do you plug into from
Yes.
the final one?
So what's an example of a point we could use in this?
Does -1?
Yeah, so let's go back up here. So if I plug in -1, so remember I said we could ignore this because it's always positive. So when we're doing sign analysis, Shukai, we're always plugging the point back in to the reference, either derivative or original equation that we came from. Michael?
Isn't the first part always negative since you took out a negative with it?
Oh,
So is it flipped?
Yeah.
So it should be, your interval should be switched, so it should be concave down where you said it was up and vice versa.
yes, fair enough. Okay, so let's redo this math, right? So we can ignore, yes, this is an excellent point. We can ignore the e to the negative x squared, but we can't ignore the -2.
Right.
Yeah.
So let's distribute that -2
Back into
back into here. So that would give us
-2
-2
plus
plus.
square.
Well,
Yeah. Equals 0.
So then it would be,
It would be positive when it's -1.
no, take that, I see what you're
It
saying.
would be
Yeah, I see.
Yep, one.
Yeah, the same thing.
it's gonna be the same. So it doesn't change our
It's
points of
just for the sign
inflection,
analysis.
it just changes the sign analysis.
Yes.
Alright, that was a good check. How can you get a smaller circle on your eraser?
There's a setting.
Like maybe I just made a small mistake, not a big mistake. Maybe I just made a small mistake. Okay, so if we plug this back in, it's gonna flip it, right? Because we've got that negative sign. So instead we're gonna have, so now explain to me, Shukai, how would we find this then?
So
Thank you for catching that.
Oh, then you plug -1 in,
Okay,
and then you will get a positive number.
you get a, so if we plug -1 in, we get a negative number here that becomes a positive because of the sign out here.
And
Is that true at 0?
It's
0 is always kind of tricky, so let's, if we set
Negative, yep.
negative 0 point something,
And then,
and then-
past that, it will be positive again.
right?
Yep, there.
So it's still agreed, are these points of inflection?
Yeah.
yeah.
But then we need to, this changes our interval. So this is concave up, concave down. Alright, so let's try to, what did you get when you plug it in? Can you guys did you already plug that in to find the points of inflection? Spencer, can you do the -1/2? Michael and Shukai, can you do the +1/2?
Wait, should it be squared?
Yeah, sorry. Michael, what'd you get for the y value for the positive square root of 1/2?